Now let's talk about the components. So as previously we've seen that if you want to be a data scientist, you have to know about the math and statistics, business knowledge, and some of the programming languages. So if I'll combine mathematics and computer, it comes to the machine learning. Okay. But domain knowledge and the computer science is just you can do a software development because there is no statistics. So if there is the only the domain knowledge and statistics, this is just like a data analysis. So for becoming a data scientist, you need to have a knowledge about programming language. It doesn't mean that you need to be a computer science guy. Just you need to be familiar with any program, okay, like a Python or R. Then a statistics, then a domain knowledge. So we'll go a little bit about that. Like we'll know about the machine learning and what kind of statistics we use in the data science, and then we'll understand about the few of the software. So firstly, the machine learning. We'll know about what is the machine learning here. Okay, so machine learning is just a scientific way to, provide a machines the ability to learn automatically and improve from the experience without being programmed. So let's say we'll put a certain algorithm in the machines, so machine can learn, and on the basis of that learning, that can predict. So generally, we put a training module inside a machine. Okay, so how you do that, you'll know that. Okay, let's see. So here you can see that like a child who is just looking at these things and you're thinking, what is this? What happens generally? We generally teach the child, okay, this is the apple, this is the orange, this is the cherry. But the first times when you teach the anyone, he cannot say that. Like in our childhood, teachers what they generally said that, okay, 2 plus 2 is equal to 4. At the at the first time you cannot understand, but when you do the practice 2 or 3 or 4 times, you can understand it. In the same way, if you tell the child, okay, this is the apple, this is the orange, this is the cherry. So that after telling 5 or 7 times or 10 times, let's say, child finally learned, and if you'll ask them, pick the apple, he will pick the apple. Pick the orange, he'll pick the orange. In the same way, we teach our machines. We put a lot of training data. In the training data, in the one side, there will be the pictures of, let's say, apple, orange, and the cherry or the other fruits. And in the output side, we put the tags. So if in the input there is apple, we'll put the tag apple at the other side. Okay. So we always labeled the data. We call it the labeling. Okay. So the output, we are giving a data, but we cannot train our machine with the 3 or 4 data points. So we put, because the size of the apple is different, it cannot be the same apple. Okay. So let's say if you put it like 1,000 of apples images, thousands of orange images, and thousands of cherry images, then now machine, and then we train our machine on the basis of that. Now machine learn that, okay, what is apple, orange, and cherry. Now let's say if you put another apple, then machine will tell that this is apple. It will classify automatically. We don't need to put a label again. So just train the machine, and once the machine will see the another unseen, another untagged product, it can classify it. Okay. So that is the machine learning. So let's go with a few of the types of the machine learning here. So there are basically 3 types of a machine learning we have. First one is the supervised learning. Supervised means to supervising someone, to telling someone something. Then once they will tell it, then they will learn it. Like here, we are supervising the child with that. This is the orange, this is apple, this is cherry. The child is supervised by either his parents, brothers, sister, or maybe teachers. After that, he is learning. In the same way, we supervise our machine to learn that this is apple, orange, and this is cherry. So this is the supervised learning. Second is unsupervised learning. In unsupervised learning, we discovered the patterns. So like let's say, now through the experience, now let's say now we are grown up and now we are in the 10th or the 12th class. Okay. Now we know that what is apple, what is this. Or maybe let's say child is now known to all this product. If you'll give him a, let's say, 100 products, 100 different items in which there are the few of, let's say 25 are apple, 25 is this, and 50 are cherry. Okay, if you ask them to just put similar fruits in one basket, and other in the other basket. So what the child will do, he'll put all the apples in a one basket, orange is the another, and cherry is the another. So this is the unsupervised learning. So we are only finding the patterns. Whatever the similar things is looking, we'll put in the one basket. So that is the unsupervised learning, where there is no supervision need for that. So like just to dividing into the different kind of cluster. Like in our class, generally what happens, male will be the one side, female will be the other side will sit. Okay, so this is the unsupervised, but they are dividing into the two parts. Third is the reinforcement learning. So reinforcement learning is basically learned based on the hit and trial method, or you can have feedback. So let's say you guys play a cricket. Okay, so let's say uh, you played a wrong shot and you got bowled. Okay, and then what happens generally, you go and see that, okay, if I play like at the point, then the shot will be the well, I shouldn't play in the straight way. Okay, it happens sometimes. Okay, so you learn from your mistakes. Okay, from these mistakes, you go and put a feedback, and next time someone will come, you will you know you'll see the better result. So you'll not do the same mistake again and again. Like you are playing a chess. So how you learn from your chess, from your winning and losing, from your experience. So this is the reinforcement learning. So this is the feedback mechanism. So whenever you are winning, you are getting some reward. Losing, you are just penalized by that. Okay. So here, for a winning, always reward. For losing, they always get some penalizations in this system, in the machine learning algorithm. So these are the three basically known machine learning algorithm right now at the high level. So it's really important to understand about the mathematics, and if you have a even little bit interest in the mathematics, okay, and you want to learn about the data science, then you know you have to ready to play with the maths. A general maths, not like the complex maths. It's just the whatever you learn till 10th, that math will be always there in the statistics. Let's say 12th, there is no any rocket science there. Okay, always understand it. Maths is really important. Yeah. Here are the few tools we generally use in the data science. Okay, so till now we understand about what data science, who is data scientist, and component of data science, what is the life cycle. Okay, now the what is the importance of machine learning and statistics. Now we talk about the third part, like the programming and tools we need to understand. Not this all programming you need to understand, but I'm just exploring, just I'm telling you the few parts, like what you can use for a data storage. Let's say we are getting a data, but you need to store somewhere. So few of the software or a few of the databases is available. It's known as the MySQL. One is MongoDB, one is Redshift. So all this name is the for data storage. For Amazon, there is the S3. Then for playing with the data, you have a Python, SQL, and Spark. For building any machine learning model, you don't need to write a code from a scratch. Okay, you can use a pre-built library which are available in the market. Okay, so pre-built library means, let's say you want to build a model for any prediction, you can use the scikit-learn and the Python. Okay, you can use the pandas for a data exploration. Okay, then comes to the visualization. There are the many tools for a visualizations in like Tableau. Tableau is the one of the famous one where you can put your data and you can get a insight from all those data in a visual format. And the few other tools, like for a big data processing, we have a Kafka for streaming, uh, Hadoop to handling a big data. So these are the tools will help for other tasks. So there is no ending tools in a data science right now, because as the data is increasing, everyone is coming with the new solution. So before that, to process 1 GB data, it takes a lot of time. And today you have to process a 1 GB data, you can do so quickly. But what will happen when we'll have a petabyte or zettabyte of the data? For that, the companies are working to scale it up. NumPy is mainly used for a linear regression, or you can say only for a maths calculation. Okay, so calculating the mathematics, NumPy is generally used. For a big data, there is a certain way to do. For let's say if you are getting a streaming data in a real time, we cannot go and play with the NumPy, but we need certain software which will help us. So for that we have a Spark. So that is working in a different way. So as I explained, pandas is for exploration, NumPy is for maths. I will explain in hands-on what how you use the NumPy, how you can use the pandas. Okay, because these two packages are really important.